We install floaters that look like little boats to existent man-made structures such as piers, breakwaters, jetties, and other types of marine structures. The floaters are going up and down with the movement of the waves. They're pushing the hydraulic cylinders, which transmit biodegradable fluid into land-located accumulators. A pressure is being built in the accumulator, so the higher the wave, the higher pressure, which is used to turn the hydromotor, turn in a generator, and when grid connected, send it the energy through the grid.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Inna Braverman, the founder and CEO of Eco Wave Power, one of the companies at the forefront of using the ocean's waves as a renewable energy source. This is something I've personally always been interested in. It seems like it could be a really important complement to the intermittency of solar and wind. I remember learning about it first back in college, which was a very, very long time ago, but I don't know of anyone doing it at scale yet. I'm curious to learn from Inna why that is and how Eco Wave Power is making it happen. Her proprietary approach uses an onshore system positioned on the coastline. I've seen some videos of it and it's super cool and I'm excited to learn more about it. To introduce Inna quickly, she co-founded Eco Wave Power in 2011 at 24 years old. Under her leadership, the company installed the world's first grid-connected wave energy array in Gibraltar. She has been named one of Wired's Females Changing the World and recognized by Fast Company as one of the world's most creative people in business for 2020. And she's the winner of the United Nations Global Climate Action Award. Inna, it's an honor to have you on the show. Thank you so much for joining.
Thank you. Thank you for having me.
So take me back to 2011. You were 24 years old. What was going on in your life at that time that led you to found this company?
So I would say, fresh out of university, like a few years out of university, and I need to go a little bit before that year of founding, really, because like I grew up in Israel, but I wasn't born in Israel. I was born in Ukraine in 1986, and 2 weeks after I was born, the Chernobyl nuclear disaster happened, which was the worst history nuclear disaster. And I was one of the babies that got hurt from the negative effects of the explosion. So I basically had a respiratory arrest and a clinical death. And luckily, my mother, who's a nurse, came to the crib on time, gave me a mouth-to-mouth resuscitation and saved my life. So I don't remember any of it. Of course, I was a baby. But when I was 4 years old, my family immigrated from the Ukraine to Israel. And, every time we would meet for holidays or family gatherings, everybody would bring it up because, that's a good story to say, you got a second chance in life. That's so cool. And that's how I learned that something actually happened to me as a baby and I really got a second chance in life. And, growing up, I grew up with a feeling kind of purpose because, not everybody gets a second chance in life. I should do something good with it. I should do something unique with it. And, when I had the opportunity to choose what to study, I actually went to study political science in Haifa University in the north of Israel in the hope of becoming this great politician and making change in the world through politics. So maybe making peace in the Middle East. That didn't work out so well as we can see. And Ukraine is also not doing so well. So yeah, not yet. Hopefully soon. So when I finished my university and I saw there's no lineup of politicians waiting to hire a young lady straight from university, I went to work as an English Hebrew translator for a renewable energy company. And while, there I discovered different types of renewable energy like solar and wind. And in 2011, they were already these fields were packed with competition. There was not too much you could innovate, There was the clear path of how to harness the energy of the sun and how to harness the energy of the wind. But everybody kept saying, all the scientists, that, the strongest force in nature is the power of the waves and also the most stable one. Yet nobody could make it a reality. So, being young, being 24, with a lot of, determination and hope and dreams, and a very kind of unique, I would say, backstory. I said, okay, wave energy is something that's really, really needed in the world. It's a huge amount of clean electricity, and nobody's doing that. Maybe I can be the first one that can achieve that. So that's kind of how I started thinking about eco wave power.
Wow. So, but I'm curious. Did you well, you list yourself as a co-founder. Did you find other people with expertise that kind of complemented yourself? Like you were a translator, a political science major. How what kind of team did you build around yourself?
So first of all, again, I was 24 when I was thinking about the idea,
Yeah.
and when I found companies. So I really started. I wasn't looking for people in the beginning. I was more like thinking about like how to make this happen. I was more researching the field, and while I was able to kind of see other companies that have unsuccessfully tried to commercialize wave energy in the past or build wave energy power stations, without breaking down and at normal price ranges. Uh, I understood what went wrong. Like all the companies that tried to do that had like a lot in common of, what's the mistakes that they made. Uh, but even though that I saw it and I researched it, like I didn't have the contacts, I didn't have the money, I didn't have the technical expertise to actually, make wave energy happen. So in the beginning, I kind of put the idea aside as like unrealistic. Like it's great that you're passionate about something, but like if you don't have any resources to accomplish it, it's kind of, difficult to pursue with full force. And then I went to a social event in Israel, and I met a serial entrepreneur. His name is David Leb, who was also very, very interested in climate change and, kind of positive impact investments. He invested in a surf camp in Panama and was giving money there to, cut nets that are catching sharks and things like that, like to kind of improve and protect the natural habitats and the environment. And when he sat down next to me and asked me, "What's your passion?" and I said, "Wave energy," it was kind of like a match made in business heaven. And he ended up investing the first $1 million, which actually enabled the official beginning of EcoWave Power from like just a concept and a dream to something like tangible.
Wow. What was your goal with that first $1 million?
So the first goal was basically to see if I had some ideas and David had some ideas of his own, and to see basically how feasible are our ideas, because at 24 $1 million sounds like a very, very big amount and very, very
Hmm.
big responsibility. So you don't want to utilize it in the wrong way, and you don't want to lose a good opportunity, a great opportunity that can really help you commercialize a new field. So we wanted to prove that the ideas that we had can actually like become a real product, that we can actually bring our vision to life. And Israeli engineers are very, very like expensive. They're considered one of the best in the world, and they're expensive for a reason. And we didn't want to open offices and hire many, many engineers in Israel without knowing that at least preliminary our concept is kind of workable.
Hmm.
Went back to the same city in Ukraine where I was born, and we did their competition between 300 engineers and identified a team of 5 that would kind of examine the concept, check if we can make the concept a reality, like actually make the blueprints and the sketches and so on. And once they kind of did few months of work and assisted us in bringing our vision to life, we also rented the wave pool in Kiev Hydromechanical Institute, also in Ukraine, in order to make like a first testing of kind of a mini model, to see how that works and to learn together with the scientists in the institute what we can do to improve it. And that's kind of how we really, really started while saving significant costs.
Mm. It's amazing how so many of your kind of life circumstances lined up to allow all this to happen. Your experience as a baby, and then your ability to be in this kind of translating position for renewable energy companies, and then your connection to Ukraine to find the engineers and the resources to do the feasibility studies. I'm curious, do you think like was this your would you have always gone and founded a company and done something like this, regardless of those circumstances, or do you more feel like everything sort of fell into place and kind of set this path for you?
I think it's hard to say, like, if you
Yeah.
eliminate certain experiences, good or bad, that happened to us, like, growing up, I think that you probably would get different results. So I wouldn't want to eliminate kind of any of the experiences, even if they were negative. But I do think that, like, everything, I would say, magically came into place because,
Mm.
again, like, think that, like, no matter how good of a will I had and how much passion I had, in the end of the day, you couldn't make this company or this product a reality without financial backing. And like, just going to a social event and meeting David there, and for him to put $1 million into a 24-year-old young lady, that's not something that happens every day. So there were definitely moments of I would call it being in the right time, in the right place, that enabled this dream come true. So I don't know, maybe in some way it was meant to be.
Yeah. Well, and you made the most of those moments. I mean,
Yeah.
um, what were you seeing at the time? You said you kind of looked at what other companies were doing and then had this concept for a different way to do it that you wanted to go prove the feasibility of. Can you say some more about that?
Of course. So when I looked into the wave energy industry, I saw that 99% of the companies that are trying to develop a wave energy product are doing it in the offshore zone. Offshore zone is like few kilometers into the ocean or into the sea. And they were all failing in the same kind of from the same reasons. So in the offshore, it was always super expensive because there's nothing there to connect to except to the seabed, and it's very, very deep in the offshore. So you need the ships and divers and underwater mooring and cables, which made the whole thing very, very expensive. There was a company that everybody knew back then. It was even, I think, in a James Bond movie called Pelamis. It looks like a big red snake that was supposed to harness the power of the waves, and they built a station that is compatible for about 100 households for a development cost of over $150 million. Like, that's super high price for 100 houses. Um, Except the cost, which was a big factor of non-commercializing wave energy in the past, there was survivability problems. So in the offshore zone, you have waves of 20 meters or even higher, like tsunami waves. So no man-made equipment can survive the loads of such gigantic waves. So Pelamis broke down after a few days of operation. And the other companies like Ocean Links in Australia and Wello Oil in Europe, like, they also broke down after a few days or a few months of operation because of the large wave and the fact that this equipment doesn't have where to hide, like, during a storm. So insurance companies were reluctant to insure wave energy, and if you can get insurance, it's very, very difficult to get also financing. So that also kind of impeded the commercialization. Environmentalists, which were supposed to be the greatest proponents of wave energy, did not really like the concept of offshore wave energy, since it's creating a new presence on the seabed and potentially disturbing the marine environment, and think how expensive it was to connect something like that to the grid, because there's no users of electricity in the middle of the ocean. The nearest grid connection point will be onshore, will be on land. So in order to connect this to the grid, not even knowing if their equipment will survive, you need to draw like a super lengthy cable from the middle of the ocean on the kind of sea ground, on the seabed,
Yeah.
to an onshore facility, which makes it even more expensive and complicated. So I said to myself, just logically speaking, like, if we can solve these 5 problems, if it can be cheap and reliable and insurable and environmentally friendly and easily connected to the grid, then it can work. Because in the end of the day, like, everybody knows that wave energy works. It's just a matter of making it, like, reliable, making it survive extreme marine conditions, because the ocean is sometimes, like, unpredicted and a little extreme, and being able to connect it safely to the grid and so on. And that's kind of the direction that we took, like, just taking an industry that already works and simplifying it enough to make it commercialized.
Mm. But there must be reasons people were doing it offshore. Is it because there's more wave power, more consistent wave power? What are the trade-offs of bringing it onshore?
So the reason of bringing wave energy to the offshore was, you're right, in the fact that you have waves in the offshore that you then don't get in the onshore, and good that you don't get them, because as I said, like height-wise, it's like tsunami waves. They're huge, and we have a lot of problems on the shoreline if we would get this wave. So yes, the scientists and the engineer behind those companies, they went into the offshore because they saw that in the offshore there's the largest amount of potential energy to be generated. What they didn't take into account is that there's a difference between available energy and exploitable energy. So most wave energy technologies are choosing to harness electricity through hydraulic principles. Meaning, let's say you have a hydraulic cylinder, right? And the more it closes and opens, like the move of the hydro cylinder is the energy that you can produce. But let's say that the hydro cylinder that you choose, because it can be like in 20 meters long hydraulic cylinder, because it would break, right? It's like going to need a lot of reinforcements. So let's say standard hydraulic cylinders is 5 meters. So every wave that you get above 5 meters will basically be working to break the equipment rather than produce electricity, right? Because your hydraulic cylinder can kind of absorb energy of a 5 meter wave height, but you're getting now 6-7 meters wave height. So it's working for breakage. So new studies are showing that while the available energy offshore is much larger, the exploitable energy in the offshore and nearshore, for example, is nearly the same. We have this study on our website, by the way, so you can see it also there. So that's one. A second thing, I would say that I do think that offshore wave energy will happen in the future. I think wave energy has potential nearshore, onshore, and offshore, like in every available zone. However, we need to be a little mindful to how other renewable industries commercialized. When we're looking at the wind industry, we see that for the first 100 years, since the first onshore, on land wind turbine was built, they only built on land. So 100 years, they built a supply chain, they lowered the cost, they learned how to reliably install where it's simple and easy on land. And only after 100 years, the first offshore windmill was built off the coastline of Denmark. Wave energy kind of went, I would say, went in the wrong way, or was overconfident. Like instead of starting where it's simple and easy, which is like onshore, on land, they went right away into the offshore where it's complicated, more expensive. Even now, windmills that are offshore cost double the price than onshore windmills. So that shows you that there's more complexity, there's more work to be done there. So I really think that wave energy has room for offshore, onshore, nearshore, and so on. Start where it's simple and easy, start where wind energy succeeded, and then go to the offshore.
Mm. Is that how you see the future of eco wave power? Do you expect to take that path eventually?
I think that right now EcoWave Power kind of enjoys the advantage of being a first mover. There's a lot of breakwaters, piers, jetties, and other structures that are available. So I don't see right now a reason to, kind of like get out of this idea of connecting to existing man-made structures and going to the offshore. In the future, I'm sure that the market and the industry would evolve. Right now, we have enough places to install. Like, unfortunately, there's not a lot of competitors in wave energy. Like, most of the companies are still very early on in their R&D. They're still in wave pool testing, on computerized simulation. I think we're the only company that is opening actual real conditions installations in such a, for wave energy, I would say, fast pace. So we definitely have enough locations to install, and in the future we might look also into the offshore. And we already did a feasibility study for Shell for potentially implementing a project on a oil and gas drilling platform in the offshore. We also had discussions with some wind developers to maybe combine, put our floaters around the base of the wind turbines. So there are creative ideas to also go past this zone where we're working, but it's R&D work for the future.
Mm-hmm. Hmm. I love that. I feel like it's a lesson I've heard from so many founders in the climate tech space that there's a lot of value in going for the kind of achievable market first. How can you as quickly as possible get early customers without, it may not be the theoretically ideal or optimized installation site or application, but it's the one that helps you get market traction, helps you learn and iterate and start to build your business. What did you learn with those first feasibility studies?
So we started the first kind of prototype in the wave pool. Basically, we were testing different floater shapes We wanted to see how the shape of the floater basically impacts the energy that can be generated. That's the testing that we've done there. We saw the workability of the technology, and we received recommendation from the scientists that work in that hydraulic hydro wave pool. So they recommended to enlarge it to greater sizes and, of course, go to a real conditions testing. And then the real condition testing, the first one that we performed was in Crimean Peninsula. So we did some testing there, already combining kind of the floater shapes that we decided upon with the first time with the hydraulic kind of drive, hydraulic PTO. And we did the testing there until few weeks before the problem between Ukraine and Russia on this territory happened. Then we moved the equipment to Israel, to Jaffa port, and continued the testing there as an off-grid kind of testing, because back then there was no regulation or legislation that enabled us to connect to the grid. And now we already are past that, and we have a grid connected the pilot in Israel, becoming the first company in history that connected wave energy to Israeli national electrical grid.
Yeah, it's amazing. And I think everybody listening should go to your website because there's some awesome videos there that really kind of bring this to life. But can you quickly describe how the system works?
Of course. So we install floaters that look like little boats to existing man-made structures such as piers, breakwaters, jetties, and other types of marine structures. The floaters are going up and down with the movement of the waves. They're pushing the hydraulic cylinders, which transmit biodegradable fluid into land-located accumulators. A pressure is being built in the accumulator, so the higher the wave, the higher the pressure, which is used to turn the hydromotor, turn in a generator, and when grid connected, sending the energy to the grid.
Got it. What have been some of the biggest engineering challenges to get to, a system that's reliable enough and functional enough to be grid connected, like you were just describing?
So I would say that the grid connection part was the easier part, because we use the whole supply chain, like from the generator to the inverter to the grid connection from Siemens. So the inverter is programmed in a way that it makes sure that the energy that comes out from the waves is compatible to the grid. So that was a easier part. But there have been like different kind of R&D and developments that we needed to undertake to make sure that the technology can survive storms and that we can more efficiently generate energy from the power of the waves. So, for example, in Gibraltar, we were stress testing the technology, like what happens if you have failures in the lock-in mechanism, because when the waves are too high for the system to handle, we lift the floaters above the water level and lock them in the upward position. So we were stress testing the equipment to see how strong our locks can be and which wave height it can withstand. Let's say if you have a failure in the lock-in mechanism. So we really focused on that there. In the Israeli project, we worked together with EDF to develop a much more advanced and much smarter control and automation system that really enables us. Like in the past, we weren't able to measure each individual wave to assess how much power this wave potentially has and how much power do we actually get, upon the or transfer to the grid or get out of the generator. And then now we developed like the ability to actually measure wave by wave, which is an in-house kind of software that we had to develop, since most existing products, they give you the wave height every 15 minutes and give it to you as an average of the 1/3 of the highest waves. You couldn't like buy a product like that, so we developed a product like that, and now we can actually assess how kind of efficient our technology is. This in the future, by the way, can be sold or given to other wave energy developers and to universities, and can maybe be used kind of as a agreed upon method to really verify the efficiency of different wave energy mechanisms. So I think this can push the whole industry to to a more advanced phase and actually enable to compare completely different technologies to each other. And right now, we keep working, we keep doing research and development to improve our generation data. So right now, let's say in Jaffa Port, we reached the point where in wave of 1.5 to 2 meters, which are kind of average waves for wavy locations, we produce about 13 kilowatts of power. on a relatively very, very small, like it's 10 floaters. So the footprint is about like 30 meters, 30 linear meters. So we already are able to produce more energy per footprint. Like if you would cover the whole floaters with solar panels, you would be able to produce about half of this energy, sometimes even less, depending on the environment. So we're already getting to a place that we can produce more per footprint. And our next goal is to lower the costs, because the costs of solar are right now extremely low. Their R&D started 40, 50 years ago. So we need to catch up. But I think we're moving to the right direction.
Yeah, tell me about that. What do costs look like now, and what's the path to get to a place where you're closer to cost parity?
So the pilots, of course, they don't enjoy economies of scale, because you're doing the same work, you're doing the same studies, you're doing the same engineering as for a big scale. So the pilots are not obviously profitable and are not cost effective with their demonstration. They're very, very cost efficient in comparison to our offshore competitors. Like, we're not in the price of 150 million. The first real conditions project that we built was in Gibraltar, and it cost us $450,000. The Jaffa project and the LA project also cost us less than $1 million each. Some of them had like some additional expenses related to research and development elements. But when we're looking at commercial scale, according to our plans and forecasts, when we reach a size of 20 megawatts, which is in simple words like 20,000 households, up to 20,000 households, then the price of each megawatt will be as low as $1.5 million, and the levelized cost of energy can be as low as $0.05 per kilowatt hour. And then, like when we reach these sizes and we start building multiple projects and not like one and then another one, then we can really be kind of on the path of commercialization, because the price is comparable to the price of onshore wind. And in suitable locations, we have the potential to have much higher capacity factors. So let's say in Portugal, the project that we're building right now that should be finalized by the end of next year, we have wave availability of around 90%. That's the forecast. So that's much higher than you would have wind or solar availability. So we will be
Mm,
able to show that we can generate significant energy amounts.
mm. Is that one of the reasons that it kind of holds up favorably to solar and wind, is just the that it's less intermittent, or it's more higher availability?
It's higher availability. It's located in a place that people actually need it, because
Mm,
two-thirds of the world population are living like 200 kilometers away from a coastline. So you can deliver electricity exactly where it's needed and where you have a lot of the grid connection points. You can actually put it in high population density centers. Like, for example, wind energy, you always have to put far away from where people live. Nobody wants a wind turbine in his backyard. It makes noise. Some people say it's killing birds, and like it has its visual impacts and problems. So nobody wants a wind turbine in their backyard. Whereas wave energy has no visual impact. Like, we put it on the outside of the breakwater of the marine structure, so it's not seen from land mostly. It's only seen like if you're coming from the seaside. It's not built for height. The height of a floater is 1 to 2 meters maximum. So has no visual impact, has no noise, and can actually be implemented in places that people need it. So I think that's the big advantage of wave energy.
mhm. Do you get any kind of environmental pushback?
Actually, no, because we install on existing man-made structures such as piers, breakwaters, jetties, and other types of structures. So these type of structures, they already destroy, or I would say impact negatively on the natural environment, because cement in the water, stones in the water, that's not a natural thing. So we take something that is actually not used for anything, like it's not prime real estate, it's just like a breakwater or a jetty, and that already damaged the environment, but has to be built in order to protect, ports or coastal populations from storm, and we turn it into a source of clean electricity. So that's a big advantage.
Okay. And I have no sense for this, but how much scale does that afford to you? Are there enough of those structures in wavy parts of the world that enable you to scale significantly?
So of course, because like every location that is wavy would need to build these structures, because they need to provide safety to the coastal population and to the ports. So every wavy population has this structure. Every structure like this is not prime real estate and is not used for anything. We can take over add our technology there, enabling it not only to serve as a wave breaker, but also as a source of clean electricity, source of revenue generation, a source of jobs to the local community. Like for the project we just opened here in the Port of Los Angeles, we used only local subcontractors for everything from construction of the floaters, installation, maintenance, like family-owned business, woman-owned business. So we're actually able to kind of really, really support local population. So I think it really has kind of a win-win, approach for implementers of the technology.
And there's sufficient there's enough of these structures in the world that that wave power could be a meaningful part of our energy mix.
There's enough of these structures. Moreover, there's more of these structures being built all the time, since there's more storms happening, maybe because of climate change, maybe because of other reasons. So more and more destructive storms are happening around the world, making more and more breakwaters in development. What I would even like to see in the future is that not only that the existing breakwaters like integrate us into them in order to provide clean electricity, but even breakwaters in the planning. Let's say that municipalities or states would be in a position to say, you want to put a breakwater, you want to harm the environment, great, you have to integrate a renewable energy source into that. And that would be real progress, because instead of trying to kind of match two pieces of the puzzle that weren't built together, you can actually build a breakwater with the connection point for wave energy.
What are some other things that need to happen to help you describe this process of scaling up and coming down the cost curve? What are some of the big things you need to achieve to do that? Are there regulatory hurdles? Is it about more of a commercial approach? What's required there?
Definitely, number one is regulation, because
Mm.
wave energy is such a new renewable energy source, and because a lot of companies have been stuck for decades, unfortunately, in research and development. There was not a lot of like physical knocking on government's door telling like, hi guys,
Mhm.
like we're ready, make legislation for us, make regulation for us. And the government and the municipalities, they tend to kind of wake up and regulate when they see something is happening. So when we announced our pilot project in the Port of Los Angeles, although it's a small pilot project, it woke up the government. They said like, wow, there's a big potential in California. Let's help them promote that, because there's a big upside if everything goes well. So then Governor Newsom signed Senate Bill 605 into law, which is meant to give budget and for R&D and for pilot implementation, specifically in California for wave energy. I think it's the first of its kind legislation. New Jersey heard that California did it. They just contacted us and said, guys, we want to discuss a pilot by the end of the year for New Jersey as well. So legislation tends to be born from actual efforts, and because there weren't too many companies of this sort that were actually wanting to implement in real conditions, there's no clear licensing pathways, there's no clear regulations, there's no clear bureaucratic kind of path for implementation of wave energy in the United States or elsewhere. So I always give as an example our Port of LA project is that we just got the final license to install this demonstration in March 2025. So it's like 6 months ago, less than 6 months ago. And by July 2025, we installed the equipment. And it took us 2 years to get the final license and 4 months to install. So
Wow.
So regulation is really, really a key component in making wave energy a reality. Like we need to work hand in hand to understand how to kind of simplify this path. And by the way, the 2 years that it took us for a new technology, that's extremely short timeline, because even right now, with wind and solar being very like commercialized sources, sometimes it takes them 8 years to build an actual like big commercial scale project, although regulation for them exists. So in general, like I think wave energy can be regulated faster, since it doesn't have the visual impact, it doesn't take prime real estate, it doesn't have environmental impact, but a regulation has to be created. And the second thing I would say is also a problem that wind and solar handled in the past and solved it successfully. So I believe we will as well, is lack of debt financing. So right now, banks do not provide debt financing for this type of asset, for wave energy farms. And that's key, because if you want to build, not like build one project with a local partner, then go look for another local partner for another project, but actually build like multiple yielding assets, multiple yielding wave energy farms in parallel, the banks need to play an integral role and fund this type of projects. And I think that's the next step. Probably when we will complete the Portuguese project, which is already 10 times larger than the size of the pilots that we have built to date, I think that would open kind of the pathway for that financing.
And that's because the banks really need to see it being proven financially before they're willing to kind of take that risk, or why is that?
I think the banks don't necessarily look at it from the technological point of view, because it's very easy to do technological due diligence. We just bring appropriate engineers and they can say that the technology works, was nothing there that's strange or surprising. But I think the banks, for them, it's most important that we know how to predict our revenue streams. Because meaning, for example, if I think that from a power station X, I would generate 1 million kilowatt hours a year. So the banks wants to see that what I forecasted is what I can generate, because in the end of the day, if you sign a PPA or you're selling the electricity to the grid, that has a price to it, and then you can return the money to the bank, you can return the debt by actually selling the electricity to the grid. And this is kind of our long-term preferred revenue stream, because in the short term, we're doing turnkey project, which means sale of small projects in order to penetrate markets. We do joint ventures like we did with EDF for the Israeli project. Shell co-funded 50% of the LA project. So that's how we do it in the short term. But long term, we really want to be owners of the assets. We want to own the power stations and not sell the actual power stations, because the profit margin on those would be smaller, but actually sell the electricity to the grid for 25 years, which is the expected lifespan of the systems.
Got it. That was going to be my next question, is your business model, but it sounds like that's clear. As I understand it, some different project developers take a different approach, but your approach is to own and operate and get margin on the energy itself.
Exactly.
Yeah, and it sounds like you get to kind of flex your political muscle a bit, paving a new way for new regulations. Are you enjoying that part of it?
I think it's very, very exciting. First of all, seeing Senate Bill 605 signed into law by Governor Newsom, that was an amazing moment. Really, a first wave energy legislation spring into action. That's a big deal. We're publicly traded here in the United States since July 2021 on NASDAQ. And in 4 years of, partial presence in the United States, to be able to actually be partially responsible or contributing to an actual state legislation, that's amazing. And right now, there's even more exciting news. Congresswoman Barragan is promoting a $1 billion legislation initiative on the federal level. So not on the state level, but federal level, to support wave energy development. So I think if she's able to really pass this law on a federal level, this would create interest, not per state, but kind of, on the whole, for all states together, which will be very, very important.
What's your vision for the future of EcoWave Power? What do you hope to accomplish?
So I definitely hope to see as many projects being implemented as fast as possible. As the entrepreneur behind the company, I hear many times, from external sources, from other people, that wow, EcoWave Power is moving forward so fast. Nobody's actually putting real conditions, installations. We have one running in Israel, we have now one in LA, we have projects coming in Taiwan, in India, and in Portugal, and everything is supposed to happen in the next 1 year to 1.5 years. That's a lot of project. It seems very fast. But to me, as a very passionate and I would say a little hyperactive entrepreneur, I would like to see it happen even faster, because there is a big potential. There are a lot of these breakwaters. They are not used for anything, again, other than breaking the power of the waves. Why not utilize all of them to produce power, clean electricity, and create clean jobs, which is something that the United States needs. All the recent studies are showing that jobs in the United States are not growing fast enough, and that we need to create more workplaces. What will create more workplaces than an energy potential that can provide, according to the Energy Information Administration, 66% of the United States energy needs. So everything makes sense. The AI industry is growing. For United States to maintain its leadership in artificial intelligence, according to President Trump, the United States has to double the amount of energy it produces. So 66% potential energy from the waves. like I would give it much more attention and make sure that it happens much, much faster. And I really hope that that's the next phase, because I think that the more energy is needed to achieve technological progress, the more kind of I'm sure that the government and the president and other states and countries in the world will open their eyes to new sources.
Wow, those numbers are insane. I had no idea. Okay, so 3 final questions for you. How optimistic or pessimistic are you about the future of the planet, and why?
Optimistic, I would say, because I think that in the end of the day, everybody wants their children and their grandchildren and, and their grandchildren to live in a safe place. And I think that unfortunately humankind is good at destroying the environment, because every time we have progress, uh, the environment unfortunately suffers from that. But I also think that people are extremely good at fixing the environment and achieving progress in positive fields. So it was people that invented the nuclear power plant that nearly took my life in 1986, but it's also people that invented solar energy and wind energy and wave energy. So I think we know how to take, we know how to give back. And I really, really hope that as time goes by, we would learn to give back more than we take from Mother Nature. And then we would have a very healthy balance.
Who's another company or individual doing something to address climate change that's inspiring you?
So there's a company called Eco Concrete. It's an Israeli company, and they developed a special cement that is like green cement that does not impact negatively the environment. Like even that you put this type of cement in the water or you build a structure from it, it enables marine life to grow on it and to attach to it versus original cement. And they have a demonstration kind of project close to our facility in the port of Jaffa in Israel. So that's how I got familiar with them. And I really like what they're doing. And it's also related to us a little bit.
Yeah, sounds like some good partnership potential there. We'll check them out. What advice do you have for someone not working in climate today who wants to do something to help?
So I think that there's a lot of room in climate initiatives. You can invent something or develop something if you're studying engineering. You can contribute by being a supplier or a subcontractor or member of a supply chain. You can contribute by simply investing in impact-related companies. So, like, there's a lot of room in so many different kind of aspects of this field that I think that really everybody can contribute in a certain way.
Love it. Inna, thank you very much for your time. I love what you're doing. I learned a lot today. Thank you.
Thank you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.